In the previous video, I gave you the relationship between a mole of a substance um, and this number known as Avogadro's constant. So now look at this relationship. One mole of a substance is equivalent to 6 times 10 raised to power 23 atoms, molecules, or ion. Now the substance here could be atoms, molecule, or ion. So when it is an atom, then you can say 1 mole of an atom is equivalent to 6 times 10 raised to power 23 atoms. So can you see? So when it is a molecule, then the same goes for, so 1 mole of a molecule is equivalent to 6 times 10 raised to power 23 molecules. So I think you can see it there. So the same goes for it. Now look at another relationship. 1 mole of a molecule is equivalent to the relative molecular mass. Are you getting it? 1 mole of a molecule is equivalent to the relative molecular mass. Now if by now probably you cannot calculate the relative molecular mass, you can watch our previous video. So now look at here also. 1 mole of an atom is equivalent to the relative atomic mass. So that we discussed that in the previous video. So now there are some questions here involving moles that we'll have to solve together. If you can make use of this relationship, you'll be able to tackle any questions involving atoms, molecules, and ion. So now let's kick off. Now the first question here says, what is the mass of 6 times 10 raised to the power 23 atoms of oxygen? Now I'm dealing with atom, so I need something like this, and I need one of these, the one related to atom. Now what is the mass of 6 times 10 raised to the power 23 atoms of oxygen? What I need is, so 1 mole of this is equivalent to the relative molecular mass. 1 mole of this is equivalent to 6 times 10 raised to the power 23 atoms. I just related them together. That's all. So now what do I do? So relative atomic mass of oxygen is equivalent to 6 times 10 raised to the power 23 atoms. Are you getting it? Is that what is the mass of 6 times 10 raised to the power 23 atoms of oxygen? So can you see the relationship? So now if the relative atomic mass of oxygen is equivalent to 6 times 10 raised to the power 23 atoms, now this is the relative atomic mass of oxygen. That's 16. So I told you in the, so now that's 16 equivalent to 6 times 10 raised to the power 23 atoms. So definitely you don't need any calculation again. What is the mass of 6 times 10 raised to the power 23 atoms of oxygen? So definitely you should know that the mass equals 16 gram. And you see the mass equals 16 gram. So that's that. You don't need much problem on that. So let's go to the other one. The other one times 10 raised to the power 23 molecules of oxygen. All you need to do, so they say what is the mass of 6 times 10 raised to the power 23 molecules of oxygen. So now go back here. 1 mole of oxygen molecule is equivalent to 6 times 10 raised to the power 23 molecule. So just relate it to the relative molecular mass. So now Rmm equivalent to 6 times 10 raised to the power 23 molecules. Can you see? So now what's the Rmm of oxygen? That's 32. So if by now you don't know how to find Rmm, you can go and check our previous video. So 32 equivalent to 6 times 10 raised to the power 23 molecule. So and they say what is the mass of 6 times 10 raised to the power 23 molecule of oxygen? So if 32 is equivalent to 6 times 10 raised to the power 23 molecule, that means this is the mass of 6 times 10 raised to the power 23 molecules of oxygen. So that one gone. So next question says, what is the mass of 3 moles of oxygen gas O2? Can you see 3 moles of oxygen gas O2? Now O2, now when it is O, that's an atom. You know that already. So when now there is O2, that's a molecule. Are you getting it? So just relative molecular mass is equivalent to, what is the mass of 3 moles of oxygen? Okay, 3 moles of oxygen atom. Okay, now look at it. 1 mole of a molecule is equivalent to the relative molecular mass. Are you getting it? So now so okay, let's start with, since they're asking for mole, let's start with mole. So 1 mole equivalent to Rmm. So the same thing goes. Then that means, so what's the Rmm of oxygen? That's that's 32. Abi, yes, iron also. So 1 mole equivalent to 32 gram. So now 3 moles will be equivalent to 3 mole equivalent to that would be, can be theory, that's 3 over 1 times 32 equals 96 gram, equals 96 gram. Can you see? So that's how that one will be. That will be 96 gram. So we are through with that already. So let's move to the next question. Now the next question here says, how many moles are there in 20 gram of CaCO3? So you are dealing with a molecule, CaCO3. So what you need to do, relate how many moles are there in 20 gram of CaCO3. Now go back to the substance. You are dealing with moles now. Now look, so 1 mole of molecule is equivalent to the relative molecular mass. So 1 mole of CaCO3 equivalent to, what's the relative molecular mass? So that's equivalent to 100 gram. Are you getting it? So now they now said what is, how many moles are there in 20 gram of CaCO3? Yeah, we should have started with mass. So now how many moles are there in it? So X moles will be equivalent to 20 gram. Are you getting it? So if you cross multiply here, so what you will have is this. So we multiply this, that will be 100x equals 20 times 1, 20, then x equals 20 over 100. So what you have is 0.2 moles. 0.2 moles. So that's that. That one gone. 0.2 moles. So now let's go. The same thing applies. That will be 0.2 moles again, 20 grams of oxygen. Now the next question is, how many atoms are there in 6 grams of carbon? Now 6 grams of carbon, this is an atom. So you need something like this. 1 mole is equivalent to relative atomic mass. So now how many atoms are there in 6 grams of carbon? Now relate, so 1 mole of an atom is equivalent to 6 times 10 to the power 23 atoms. So that will be RAM equivalent to 6 times 10 to the power 23 atoms. And you see we are dealing with atoms now. So now so what's the relative atomic mass of carbon? That's 12. So that's 12 gram. Okay, 12, and let's use gram of 12. So 12 gram is equivalent to 6 times 10 to the power 23 atoms. So now if it happens like that, then 6 gram, okay, sorry, then 6 gram will be equivalent to let's say 6 over 12 times 6 times 10 to the power 23 atoms. So 6 over 12, that's 1, 6 here, 1, that's 2, that's 1 over 2. So if we divide, that's 2 here. So what we have is 3 times 10 to the power 23 atoms. So that means 6 grams of carbon will contain 3 times 10 to the power 23 atoms of carbon. So that's that. So next question is, how many particles are there in how many particles are there in 0.1 mole of sulfur? Now 1 mole of sulfur, now look at it. 1 mole of sulfur, that's the sulfur. So 1 mole of sulfur contain, so this thing you can consider by atoms, molecule, or ion. That could be particle. Are you getting it? So 1 mole of sulfur is equivalent to 6 times 10 to the power 23 particles. So now 0.1 mole will be equivalent to 0.1 mole will be equivalent to let's say 0.1 over 1 times 6 times 10 to the power 23. So when you do that, that should be 0.1 times 6. It should be 0.6 times 10 to the power 23 particles. So I think you are getting. So that's that. So the same way it goes. Let's move to methanol. They said how many particles are there in 32 grams of methanol? How many particles are there in 32 grams of methanol? So what you do is this. Methanol is a molecule, so it's not an atom. So what you do is this. Since one mole is so just relate the relative molecular mass and this number here. So RMM equivalent to 6 times 10 to the power 23. So when it happens like that, the next thing is that what's the RMM? That's 32. That's 32 gram equivalent to 6 times 10 to the power 23. Can you get it? So because 32 is equivalent to 6 times 10 to the power 23, so and you are given 32 here, you don't need to go further. So that means your answer will be 32 grams. That means there are 6 times 10 to the power 23 particles in 32 grams of methanol. So I will leave you to do the last one. So just submit the answer in the comment section. Thank you. Don't forget to subscribe and share with others. Bye.